Hi Jennifer.
Hi. Sundar.
நான் உங்களை ஹோஸ்டா மாத்திடுறேன்.
ஓகே.
இப்போ வந்து நீங்க ரெக்கார்ட் பண்றீங்க ஆட்டோமேட்டிக்கா. இப்போ நான் இதை எக்ஸிட் now will anything happen? ஜெனிஃபர் நான் எக்ஸிட் பண்றேன். உங்களுக்கு இந்த வீடியோ சைன் அப்படியே பிளிங்க் ஆகுதான்னு பாருங்க உங்க நேம் அண்ட.
ஓகே.
அங்க கிளவுட் ரெக்கார்டிங் தெரியுதுல்ல?
தெரியுது. செக் பண்ணு.
வாட்ஸ்அப் வெரி க்ளோஸ் சார். வெரி க்ளோஸ் சார். சரி க்ளோஸ் பண்ணுங்க. உள்ளே தூக்கினே போய்க்கிறானா எங்க நாட்டாக்கு தெரியாது.
Hi Swati, good morning.
Hi, good morning. We are expecting Ranjit and possibly Sundar, right?
I think Sundar and Ranjit will not join the call.
Okay.
Ranjit sent message yesterday. Said.
Oh, right. Yeah. So it's just us, right?
Yes.
Okay. So thanks for sending in the proofs, etc. So the recurring decimal part is good, and I'm glad that Bakalakshmi updated your task because otherwise I was not clear what was happening. Okay, so the Excel definitely helped, and you could see certain patterns. And I think the first task both of you have done in the similar, both the proof tasks you have done in the similar way. Okay. And however, what Ranjit found is actually pretty interesting. Did you take a look at that?
Not at Swati. He sent just 10 minutes before.
Right, 1 second. Let me see if I can show it to you, it is quite interesting actually. Okay, meanwhile, let me just mention, I think Ranjit sent the monthly teaching plan, etc., which is centrally decided by the Tamil Nadu state. If you can, for class 10. So if there is a similar plan for class 9, if you can share that, that will be good.
I don't have any plan. I will create and send it to you, Swati.
No, I mean, what we want is there a central state level plan that is there?
I don't know about that. I'll ask Ranjit. I'll discuss with Ranjit and
Yeah, just
let
check
you know.
with him, and because that's important.
Okay. Okay.
So that we have a sense of what is there for class 9 also. He sent something for class 10. So yeah. Okay, I have managed to download it. Now let's see how long it will take to open. The proofs that you sent is what I was kind of expecting. Except, I mean, it needs to be tweaked a bit, okay? So, let me get to the whiteboard. See, you need to start with what is given. So, P by Q is less than R by S. This is given, right? So, you need to start from there, and we need to prove that P by Q is less than P plus R by Q plus S, and that is going to be less than R by S. Okay. Now to do that, so there are two parts to it. You can take each part. So this is less than, this is one option. Okay. If and only if. Okay, and this is in short written as this if with double F. Okay, if and only if, and now you can do the cross multiplication. Okay, no, I didn't do it correctly. Did I do it correctly? Yeah, I did it correctly. Okay. P times R plus S less than Q times. Okay. Okay. Now that is true if and only if you have PR plus PS less than PQ plus Q square. Oh, I see. I see what happened. This should be an R and this should be a Q. That's why it was going wrong. Okay. So this should be Q and this should be R. Okay, so PQ plus PS and PQ plus PR, QR. Okay, which is true if and only if. So PQ is the same, so PS is less than QR, which is true if and E by Q is less than R by S. Okay, now this is given, so this is true. Okay, so this last line is true, that therefore all the way up this is true. Okay, so you have got the steps, but along with the steps, because the starting step is what you need to prove, you need to write these extra things, that this is true if and only if, then the next step, if and only if, next step, and so on and so forth. Okay, so these parts need to be written. So otherwise the proof is not complete. Okay, because you have to go from what is given to what you need. So similarly, the second inequality can also be shown. Okay, so what I would like you to do is to modify your proof along this line. It's very small, but you can just simply modify it slightly. Okay.
Okay, Shwati.
Okay.
You see the difference, na?
Yes.
Yeah. Okay. Now, as far as the task 3 was concerned, I think you did a good job, both of you, and there were 3 parts. Okay, so you had to show okay, so you had to show that if so A is rational and root B is irrational, so you have to show that A plus this is rational, this is irrational, this is there were 3 of these. Right? So there are total 5 of this. Now, do you notice that they kind of fall into 2 groups? Do you see that?
Yes.
Yeah, so what are the 2 groups?
One is addition.
So these 5 fall into 2 groups. So which 2 are in the first group?
First one and second one, addition and
Exactly.
subtraction.
Right? because
Yes.
in both of these you get your x to be which was x was, so you assume that this is x rational, okay, and then you show that square root b is of the form p by q, right? That is what you show, and in both
Yes.
cases it looks like, so you look at x is equal to m by n,
Yes.
right? And you had a as also I think p by q, so this one turned out to be I think pn minus plus minus, you know, once it was plus, another it was minus. uh, so first case it was minus qm by qn, yeah, something like that, right? That's the form you got for square root of v, right? And in the other case you got, so this is what you got for 1, and for 2 it was identical except this was a plus or this was a minus. No, this was throughout a minus. I guess the sign changed or something. Okay, I know. Okay, so this was qm minus pn, and this was pn minus qm. I think that was the difference. Yeah. And so let me just add a equal to p by q, right? So this was the difference. So they are basically, you know, opposites of each other, additive opposites of each other, right? And in these things, it was slightly different because you basically got it as a quotient. So if this is equal to x, then your square root of b turned out to be a by x, which is pn by qm, right? And similar things happened for these two as well. So here it looked a little bit more complicated, and here it is kind of straightforward, right? Now, do you know what this kind of proofs are called? There are different types of proofs, and these are one kind of proof.
No, Swati, I don't know.
Okay, so it's a good to know because you got the proof, right? It was done nicely. These are called proof by contradiction, okay? Because what happens is you are assuming it is going to be, you have to show that it is an irrational. All these sum, difference, etc., product and quotient. So you have to show it's irrational, but what you start out with is you start out by assuming that it is rational, right? And then you get a contradiction. So the moment you write square root of b in this form and you conclude that this is a rational number, that is a contradiction. So these type of proofs are called proof by contradiction. Okay, and it's a good idea to, you know, to prove things this way when you don't have an idea. Okay, you can start with this and say, you know, let's see if we can get into a contradiction. Okay, so this is one category of proofs, whereas this one is not proof by contradiction, as you can see. This is more direct. Okay, you see the difference in the two?
Yes. You
Yes.
Okay, okay. Now let me show you what this guy came up with. Ranjit came up with. He found it somewhere. Okay. Right. Yeah. Okay, so let me magnify this, otherwise you can't see anything.
That's a screenshot, I think.
Yes, it's a screenshot. I'm trying to magnify it and it's not. Okay, now. Okay, I was trying to magnify something else. Okay. So the crucial idea here is that you think in terms of uh, coordinates and slopes. Okay. So you have a by b, which is less than c by d. Okay. So you plot this point A, whose coordinates are a comma b. So its slope is actually b by a. No, its coordinate is b by b comma a. So its slope is a by b. Okay. And you plot this point B, whose coordinates are d comma c. So its slope is c by d. Okay. And you know, so since a by b is less than c by d, this slope is steeper, right? So that is why this line is closer to the, has a smaller slope, it's closer to the x-axis, and this one is closer to the y-axis. Clear so far?
Yes, yes, sir.
And what they do is then they complete the parallelogram. Now when you do that, this C has coordinates b plus d comma c plus a. So the slope of this OC is a plus c by b plus d. Okay, so we had a by b here, c by d here, and this is the combined one, a plus c by b plus d. Okay. The interesting thing is when you complete the parallelogram this way, this line has to be between these two lines. Therefore, the slope has to be in between these two. Okay. So in this way, this is a visual proof and a very, very neat one. Now, if you're doing this in class 9 level, coordinates are already, children should be already familiar with coordinates to begin with. And, you know, if you have covered slope, then, and they know about parallelograms, etc., then it kind of makes an, you know, makes sense immediately. Okay. So I need to thank Ranjit for, you know, digging this up. It's a neat, beautiful visual proof. Okay. These are sometimes called proof without words. The thing is, this is not a specific case. See here, A, B, C, D are kind of general. The only restriction being that A by B is less than C by D. Okay. This A can be anywhere here. The B can be anywhere here. Okay. And it will still work. So if you want, you can actually do a GeoGebra sketch and vary A, B, C, D and see that, you know, no matter what, as long as A by B is less than C by D, it works. You always get this slope here in between, and that's how you get a rational number in between. Okay. So I thought It was a beautiful thing that he dug up, and it's worth mentioning that. And this is a power of, too many minds working on something, because then you look for stuff online and you come up with beautiful things, which it's impossible for just one person to do. Okay. Not all visual proofs like this are proper proofs. The key thing is generalizability. Okay. So for example, somewhere I saw this proof of Pythagoras. Okay. So what they had is five triangle, and okay, so definitely a right triangle. Now the way the proof went is, there was a groove here, okay, which was filled by 9 squares. And there was another groove here, which was filled by 16 squares. Okay, and then there was another big groove here, and the idea was that the user is going to pick up all these 16 plus 9, 25 squares and fill them here. Okay, the thing is, this is very, very specific. Okay, it will work for, this method will work for a 3, 4, 5 rectangle. It will work for 3, 4, 5 triangle. It will work for 5, 12, 13. Okay, but it will not work for any general right triangle. In particular, it will not work for a right isosceles triangle, right? So if these two sides are equal, then, if this is 1, this is 1, this is root 2, right? Now, this method is not going to work here, because for this method to work, you need all three to be rational, and definitely root 2 is not rational. So it's not going to work there. So that is where this is not generalizable for any right triangle. So that is why there is a problem. So this is not a good visual proof. Okay. So, however, Pythagoras does have tons of visual proofs. So let me share one of them, and it's a kind of neat one. So, okay, let me share a PPT, because there it is done much more neatly. Give me a minute. Okay, so you take this to be N. So this side is A, this is B, and then you put the C this way. See, I had to overlap because, so now this one is cut along the center, okay? Now, you have this triangle. So what is happening? You get the center of the square by joining the two diagonals. So that's the center. And then you draw a line which is parallel to this hypotenuse. Okay, that's how you draw this line. And then you draw a line which is perpendicular to that line. So that is how we got this. Okay, these two lines are like that. Okay. Now what we do is, now we are going to rearrange these four. So you imagine that the square has been split in four. So we rearrange them like that. Okay. And we get a square in the square shaped hole in the middle. And we fill that by this small square, that was B square. And this total turns out to be the C square.
Swati, your voice is breaking. We can't hear you.
Yes, Swati.
This is something that you do with, and here now, start with any right triangle. To draw a right triangle according to their choice. Okay, it can be a long one, long thin one like this. Okay, or something more like an isosceles right triangle like this. Okay, it's fine, whichever way they draw it. Okay, then they need to draw two squares on each leg. Okay, so they need to draw this square and cut it out. Then they need to draw this square. Okay, and then they join the diagonals. So then the center will be somewhere here. Okay, and then you draw a line which is parallel to this line through here. Okay, and then a line perpendicular to it through this point. Okay, and then you cut up these four pieces. So you cut up this one, you cut up these four. Okay, so then you rearrange these 5 pieces out here. So this piece will come up here like that. Okay, this one goes here. Okay, then this one will go like this. Okay, so you arrange them, and then the middle one goes and sits in the middle, and you will see that it gets completed. Okay, now this one is generalizable. Okay, so this one will qualify as a visual proof for Pythagoras, whereas the previous one with 9 and 16 squares won't. Do you see the difference?
Yes.
And you can also create a GeoGebra sketch and try the same thing. It works. Okay, but it's more fun to probably do it by hand and then rearrange the pieces together. If you use a stiff paper or a cutout of a box or something, that will work even better than paper, because paper may be too thin.
Okay.
Okay, so this is something that you can try it out. I'll share the PPT. I believe you guys have some model of showing Pythagoras. That is fine, but this also kind of works. Of course, you can do many more math and stuff, and you can figure out exactly. So if this is A and this is B, you can try to figure out what are the exact dimensions of each portion and etc. etc. So those things can be worked out, no problem. But it just works. Okay, so I wanted to share that with you. So you saw that there were at least 3 different kinds of proofs that are there, right? There is the regular, straightforward, direct proofs. There is proof by contradiction, and then there are visual proofs. And one of the most fun things that math can offer is to come up with visual proofs. Now, I have a strong feeling that all the results that are there involving whole numbers and stuff, natural numbers in particular, almost all of them seem to have some kind of visual proofs, etc. When we talk about AP and GP later on, I will show you, what we mean by that. And the AP sum proof is actually inspired by Gauss. So we'll talk about it when we get there. But this is a quite interesting and fascinating part of mathematics. And it's a lot of fun to come up with good visual proofs. Okay, so it gives you a lot of good feeling, as if you have discovered something or you have created something beautiful. You get the same kind of feeling out of it. Okay, so that is there. Okay. Oh, before that, the recurring decimal part. Now, I think one of you, if not both, you found out the recurring, found out the numbers for the recurring decimal expression for each one, and so the numbers kind of come in different groups. The first group, of course, is the terminating decimals. So these are the ones where the denominators are 2 to the power m times 5 to the power n. They look like this, right? These are the ones. Then the next ones that have a period of 1 are 3 times 2 to the power m times 5 to the power n, or 3 squared times the same. Did you notice this? Or maybe I should just write 9 here. Did you notice that all the numbers which had periodicity 1 fall in this category? So they will be, I think, 3, 6, 9, 12, 15, 18, and things like that, right? 30. Yeah, I think this will have just 3 and 9, and the rest will be, you know, all these numbers. Okay. Now, can you guess why I put 3 and 9 in the top and the rest below?
It's 3 and 9 multiples. Maybe.
What are the recurring decimal representation for 3?
0.333.
0.333, right? And for 9?
0.111.
Right. What about any of these?
It's 0.661. 0.666.
Right? So you see in 3 and 9, there was no, it's purely recurring. Right?
Yes.
Whereas for 6, there is a non-recurring part here. For 12, what do you get?
0.
Then? You did this.
8,
0, 8, and then?
3, 3, 3, 3. Zero, 8, then 3, 3, 3. 3. Yes.
Right? So again, you see there is a non-recurring part before it. Okay? Now, all of these, this 6, 12, 15, 18, 30, all of these, they have a factor of 2 or a factor of 5 or both. The moment these 2s and 5s come in, they will generate a non-recurring part in the at the beginning. Okay?
Okay, sure.
So that's the interesting thing. Now, then if we look at those with period 2, which are the numbers which have period 2?
11, 22, 33, 44, 55, 66, 88, 99.
But not 77.
It's not 77.
That's very interesting, right? Okay. Now again, I split them in two parts. Can you guess why? So this is going to be, if I remember correctly, 0909 like that.
Yes, 0909.
Yeah. And this is probably 0303 like that. And then, okay. First of all, I should not be saying equal to, but rather I should do an arrow. Equal to is not correct. Sorry. You need to be very careful about these kind of notations when it comes to mathematics. Zero point 0.0101. Right? Now, these do not, 11, 33, 99 do not have a factor of 2 or 5. Okay, whereas these all have a factor of 2 or 5. Okay, so that is why they will have something non-recurring in front of them. Okay, and it's a very interesting thing to observe that 77 is missing from this. Okay, now then there is the things with period 3. Now what are the numbers with period 3? I believe 27 is 1. I'm guessing that 54 will be another.
37, 54,
Okay.
74. 74.
Okay. And that's about it, right?
Yes.
Okay. And again, the same reason I have split it that way. Now there is, I believe there was nothing with periodicity of 4.
Yes.
Then we had period of 5. And which came into the period of 5?
41 and 82.
41, which was, I think, the pure decimal, and then 82. Okay. And then let's see. Yeah. Then we had something for period 6. What was there for period 6?
7.
Okay.
13. 14.
Let me put this. 7, 13. What else?
14.
Right.
21. 26.
28 would also be there, right? 26, yes.
Yes, 26, 28.
26, 28.
35.
Okay.
39.
Okay.
42. 52. 56. 63. 65. 70. 77.
Wait. 63, 65,
65.
70, right?
Yeah, yes. 70,
70, then you said 77,
78, 84.
anything else?
84.
91,
91 plus 8, I think. Yes, 91 also.
because see 91 is 7 times 13. Okay. Okay. And then there was another group of period 7, right? There was one more group, right? Was there?
I think we don't have period 7.
So in which group did 49 come in?
49. And I missed out 49.
But you guys did it exhaustively, right? So you can figure out where is 49. Okay, so the key idea here is as follows. If you convert these recurring decimals, okay, for period 1, if you convert these things into recurring decimal, okay, they will all look like some number by 9, okay, or something by 90 or by 900, something like that. Now notice that 9 is, the factors of 9 are 3 and 9, right? The non-trivial factor, that the non-1 factors. So that is why when you have a 3 or a 9, you get this, okay? Similarly, when you think of period of 2, okay, then it will look like something over 99 or something over 990 and so on. So you have to, so there will be a 99 there. Now what are the factors of 99? 11, 33, 99. So you can guess what will be it for period 3. What will come in the denominator? Can you hear me?
Yes, you can hear.
So if you have a periodicity of 3, so what will come in the denominator?
999.
Exactly. And or 9990, right?
Yes.
Etc. Now notice 999 is 9 times 111, which is 9 times 3 times 37. So now you can see why you have got this 27 and 37. 37 is straightforward, clear. The rest is 27. Smaller
It's breaking,
9
Swati.
and 3 are already taken care of, which is, so you need to have minimum 3 cubed, 27, to have periodicity of 3. Could you get that last part?
Yes.
Okay. Similarly, you can take a look at this. This will be 9999, 4 nines, and you can try to, sorry, 5 nines. You can try to factorize it and see what you get. Similarly, when you have a periodicity of 6, this will have 6 nines. So this can be split as 999 times 1001. Yeah. And then you can see what all is there. So you got 27 times 37 from the first. Then it will be 11 times 91, which is 7 times 30. Okay. So these are the numbers. So 27, 37 has already been taken care of. Notice that 11, 7, 13. Okay, 11 also. So 7 and 13 are what is coming here. Okay. However, 49 doesn't come here. So for 49, something else has to happen. So you have to find I don't know how many nines it will take, which will be of the form 49 times n. Okay. Now, the reason you don't have periodicity of 4 is because this is 99 times 101. Now, we have taken care of the 99. Okay. Now, 101 is beyond 100. We only did up to 99, right? So that is why we missed that periodicity of 4. Okay. So this is kind of interesting because you look into what happens with these numbers, 999, 999, 4 nines, etc., like that, and their factors give you a clue into what is happening. Okay. Now I have shared with you this article. Okay. And if you now read through it, you will get what is happening. Okay. It
We can't hear you, Swati.
And much more than that. So it will be help you consolidate. So that's all today. I will have covered today.
Swati, we can't get
Class
you.
9.
Your voice is not clear. She left.
Okay. in the state level class 9 wise split. Okay. And read the number chapter in class 9 and 10. Share the questions, comments you have. So you want to jot down what you liked, what could be done better, and how. Or maybe I should put it here. Okay, so that is your task for today.
Okay, Shwati.
Okay, that you are not able to understand or you have additional questions, please go ahead and share.
Okay, sure.
Okay.
And do share this task with Ranjit.
Okay, sure.
Okay. So that's it for today. It's 11. So see you
Yes.
on Tuesday.
Okay, thank you.
Thank you.
Okay, bye.
Bye bye. Take care.